Hello everyone. In this video, we are learning about momentum and law of conservation of momentum. So what is momentum? Imagine there is an object of mass m. This is the object. And this object is moving with velocity v in a straight line. So this v is the velocity of the object. Then the momentum of object is defined as the product of mass and velocity, and momentum is denoted by p. So I'm writing here p is equal to m into b. It means momentum is equal to mass into velocity. Now, since we know what is momentum, there must be some unit for the momentum. So what is the unit for momentum? Let me change the color of pen. Unit of momentum you can find by using this formula. So unit of P, which is momentum, is unit of mass kg into unit of velocity, which is meter second power minus 1. So unit of P is kg meter second power minus 1. Now sometimes you will find that there is change in momentum of the object. So change in momentum we can understand by using this diagram. Imagine there is a mass m. This mass is moving with some initial velocity u. This u could be, let's say, 5 meter per second. This is the initial velocity. Now after some time, the mass m gains velocity, let's say v. So imagine the velocity of this mass becomes v, which we can take as, let's say, 10 meter per second. So what we can observe here, compared to initial velocity, there is change in the final velocity. So we can say in the beginning we have initial momentum P is equal to m into u. I'm using the definition which we have studied just now. And final momentum Pf is equal to m into v, right? And just for the notation purpose, I will add here I. So pi is equal to m into u and pf is equal to m into v. So to find the change in momentum, we can write delta p. This delta p represents change in momentum. Change in momentum will be is equal to final momentum, which is pf, minus initial momentum pi. So what is initial momentum and final momentum? We already know here, it's given to us. So we can write delta p is equal to mv minus mu, right? So this is change in momentum, and unit of change in momentum will also be same. So that will be kg meter second power minus 1. So now let's solve two very simple questions related to momentum to understand momentum better. And the first question is a car of mass 1200 kg. So the mass of car which is given to us is 1200 kg, is traveling at a speed of 25 meter per second. So the speed of car is 25 meter per second. Calculate its momentum. So as we learned just now that momentum is denoted by P, and the formula of momentum P is equal to m into v. So we can write here 1200 kg into 25. That will give us, now we need to multiply 12 with 1200 with 25. That will give us 25 into 2. It will give us 50, and then 25 into 125 plus 5, 30. So we are going to get units, tens, hundreds, thousand, 10,000. How much? 30,000. And what is unit? Kg meter second power minus 1. So the momentum of the car is 30,000 kilogram meter second power minus 1. Now in the next question, an airplane with a mass of 100,000 kg is traveling at 250 meter per second. What is its momentum? So again, we can use the same formula. P is equal to mass into velocity. And what is mass? It's 100,000 kg. So here I can write 100,000 kg into 250 meter per second. So what we are going to get here? We will get 250, and after that 5 zeros. And we can write in scientific form 2.5 into 10 power. Let's count the number of zeros here. 1, 2, 3, 4, 5, 6, and one more non-zero digit. So this becomes 7. So 2.5 into 10 power 7 kg meter second power minus 1. This kg, be careful, this k is small, not capital. So kg meter second power minus 1. Now our next topic is law of conservation of momentum. So here, law of conservation of momentum. So please note down the topic. And to understand the law of conservation of momentum, I'm taking two masses. Let's say one mass is m1 and another mass is m2. And the mass m1 is moving with initial velocity u1 and mass m2 is moving with initial velocity u2. So now imagine they both will collide after some time. To make the collision happen, what I'm taking is, I'm taking u1 greater than u2 so that this mass m1 can hit m2. So once these two masses collide with each other, what will happen? There will be transfer of momentum between the two bodies. So this situation is before collision. Before collision. Imagine after collision, what will happen? After collision, the mass m1 transfers some momentum to m2, and due to that, let's say the speed of m1 becomes v1 and the speed of m2 becomes v2. Okay, so there has been the exchange of momentum. Let's write the initial momentum of m1 before collision. So we can say the initial momentum of m1, which is I1, I can write m1 u1. Similarly, initial momentum of m2, so pi2 is equal to m2 u2. So I'm not doing anything new here. I'm using the same formula of momentum which we have studied just now, and I'm writing the momentum of two masses m1 and m2 before collision. And momentum of the two masses after collision would be, let's say that is pf1 would be is equal to m1 v1, and pf2 should be is equal to m2 v2. According to the law of conservation of momentum, the sum of initial momentum of the system, it means when I say system, we are considering both the masses together. So initial momentum of the system is equal to final momentum of the system. So what is total initial momentum of system? We have just written here. In the beginning it would be m1 u1 plus m2 u2, which should be is equal to m1 v1 plus m2 v2. So what you can see, total initial momentum is equal to total final momentum, and this is here called as the law of conservation of momentum. In next video we will solve some questions related to law of conservation of momentum. Till then, keep revising.